Hello and welcome to my channel Pharmacy in Depth, where we'll talk about pharmacy related topics in detail. Today we will study about microemulsions. We will see what are microemulsions, what are different types of emulsions and different types of microemulsions, what are its advantages as compared to other dosage forms, and what are its industrial applications. So, a microemulsion is a homogeneous, transparent, and thermodynamically stable dispersion of water and oil which is stabilized by surfactant and co-surfactants. Now let's see how these three phases, that is oil, water and surfactant, are arranged. Considering it to be an oil in water emulsion, so we have a hydrophilic phase which is water, a hydrophobic phase which is the oil, and we have surfactant and co-surfactant at the interfacial space between the two phases. The hydrophilic head of the surfactant and co-surfactant is aligned toward the water phase and the hydrophobic tail is aligned towards the oil phase. The concept of microemulsion was introduced by Hoare and Schulman in 1940s. They prepared a quaternary solution of water, benzene, hexanol and K-oleate which became clear upon addition of a short chain alcohol. And in year 1959, Schulman and co-workers coined the term microemulsions. Let's see some advantages of microemulsions. So they are thermodynamically stable and hence have a long shelf life. Microemulsions act as a super solvent for drugs which are hydrophilic and hydrophobic in nature. Small droplet size has large surface area and hence it helps in absorption of the drug from the intestine. They are easy to prepare as there is no significant energy required to prepare them. They have low viscosity and are used for taste masking. But they have some disadvantages also, like they require large amount of surfactant and co-surfactant to form a stabilized droplet. There is a limited solubility of high melting substances in microemulsions, and the stability of a microemulsion is influenced by parameters like temperature and pH. Let's see what are different types of microemulsions. So there are basically four types of microemulsions. Windsor 1 or oil in water type emulsion. In this there are two phases, one is oil phase and second is water and surfactant phase. Windsor 2, which is water in oil type emulsion, which is also having two phases, one is water phase and second is oil and surfactant phase. Windsor 3 type, which has three phases, one center one which is the microemulsion phase, and there is one oil and water phase. In all these three types, Windsor 1, 2 and 3, there exists an equilibrium between these different phases. And there is Windsor 4 model, which is a complete microemulsion, which is uniphasic. Now let's see a comparison between emulsions, nanoemulsions and our microemulsions. So emulsions are white or opaque in color, nanoemulsions are transparent but with a bluish tinge, and microemulsions are transparent or clear in appearance. The globule size of emulsion is 1 to 20 millimeters, that of nanoemulsion is 20 to 50 nanometers, and that of microemulsion is 10 to 100 nanometers. Emulsion is a biphasic system, whereas nanoemulsion and microemulsion are monophasic. Talking about the stability, emulsions are kinetically stable but thermodynamically unstable. Nanoemulsions are kinetically stable and are thermodynamically unstable, but microemulsions are kinetically unstable but thermodynamically stable. Emulsions are prepared with intense agitation. Nanoemulsions are prepared by use of high energy instruments like probe sonicator or HPH, but microemulsions are formed by just gentle mixing. The surfactant concentration in emulsion is 2 to 3%. In nanoemulsion it is 3 to 10%, and in microemulsion it is more than 10%. The surface tension or the interfacial tension of emulsion is very high. That of nanoemulsion is also very high, but of microemulsion it is very low. Co-surfactants are not present in emulsions, but they are present in nanoemulsions and microemulsions. The viscosity of emulsion is high and that of nanoemulsion and microemulsions is low. Now let's see different theories of microemulsion formation. The first one is the interfacial or mixed film theory. According to this, microemulsions are formed spontaneously due to formation of a complex film at the surface by the mixture of surfactant and co-surfactant, as a result of which the interfacial tension reduces. This is the equation which tells that the interfacial tension, which is gamma I, is equal to the interfacial tension of oil and water without the surfactant minus the spreading pressure, that is pi I. When the mixture of surfactant and co-surfactant is added to the oil and water mixture, minus pi I value increases, as a result of which the interfacial tension decreases. and the microemulsion is formed spontaneously. Second theory is called the solubilization theory, according to which microemulsions are considered to be thermodynamically stable solutions of water solon in case of water in oil emulsion and oil solon in case of oil in water emulsion, spherical missiles. So it considered emulsions to be a solution of solon missiles which has a high capacity of solubilization of drugs. The third theory is the thermodynamic theory, according to which the free energy of microemulsion formation is dependent on the role of surfactant in lowering the surface tension at the interface and increasing the entropy of the system. This is its equation, which says that the Gibbs free energy is equal to the product of surface tension and the increase in surface area minus the product of temperature and the entropy change. Now, for a microemulsion to form spontaneously, the Gibbs free energy should be as low as possible. So when we add a surfactant, it will reduce the surface tension, but there will be an increase in the surface area because the large oil globules are getting broken down into many small droplets, as a result of which the product of gamma and delta A is a high value. To get a low delta G value, the product of T and delta S should be higher than that of the product of gamma and delta A. So the surfactant also increases the entropy of the system, which reduces the delta G value of the microemulsion. Here is a list of commonly used oil, surfactants and co-surfactants in a microemulsion formulation. Microemulsion formulation, we need to prepare a ternary phase diagram. In this, we take surfactant and aqueous phase in increasing and decreasing ratio respectively, and we add oil phase to that. We add oil phase until the turbidity appears in the system. So when we add oil slowly dropwise into the system, it is getting cleared because the surfactant is able to get it solubilized and we are getting a microemulsion. But when we keep on adding the oil, the amount of surfactant is unable to make it solubilize into the system and hence we get a white turbid system, which is the end point of our oil addition. That is why when the concentration of S mix increases, the amount of oil added also increases in the system. After doing this, we calculate the percent of all the three phases in the system and we plot it on a ternary phase. So this region we got after plotting is called the microemulsion region. So if we take any region from this region, suppose we take point A and prepare the microemulsion. So point A is having oil phase 15%, aqueous phase 30% and S mix 55%. Then we will get a clear transparent microemulsion. And if we take any point above this line, then we will get a turbid biphasic system. All about microemulsions. Thanks for watching the video. I really hope you liked my video, and if you did, like it, share it and subscribe to my channel.